Hello everyone, this is Michael, and today I wanted to go over a general overview on how I go about analyzing ransomware. Now, full disclaimer, I am not a professional malware analyst, so don't take this as a complete holy grail of how to actually do this. I kind of am still a beginner myself. So when it comes to ransomware, there's definitely a few very interesting things that we're going to be looking into. My goals are typically, first off, identifying and confirming that this sample is actually ransomware. Second off, how can we identify it? So does it have anything particularly interesting about it? Does it use an extension, a file marker? What type of ransom note does it drop? And then also, can we match it with another ransomware? Is it just an existing variant, or is it a completely new family? So today I have this sample in my virtual environment. Always, as a reminder, always do malware analysis in a virtual environment. I personally use VirtualBox. It is free, and I just have a Windows 7 station here with a snapshot. That's a little outdated, but it gets the job done. So, just kind of going over some of the tools. I transfer my samples to my box using FTP. That way I can control all the permissions and hopefully not get an outbreak. The virtual machine is on a NAT on my system, so it can connect to the internet, but cannot talk to any systems on my network. So to begin with, typically I will try to figure out what type of an executable I'm working with here. So there's a few tools we can use here. There's one called DIE, or Detected Easy. We'll go ahead and open that up and drag the executable into it. Now this will show us what type of compiler it detects it as. So in this case, it's a C++ virtual executable. And that means that we don't get lucky. We don't get to just decompile it like Python or .NET or something, unfortunately. Would have to take this into a disassembler. So this will definitely give us a path of which tools we need to use to further analyze this. This tool also will show you the entropy, which is very useful to get. It's not 100% accurate, but it gives you a good clue whether this is packed or not, meaning that there's going to be more work to get the real executable out of this to be able to analyze it properly. In this case, I have a sample that's not packed because I want to be easy on myself. So another tool that is very helpful is PE Studio. This is just great for basically any malware analysis. We'll go ahead and open this up. Of course, I'll have links to all these programs in the description, along with a link to the sample. So just kind of generally what I'm looking for when I'm taking a look at, once again, the signature can confirm what type of executable we're looking at. In this case, it was compiled with Visual C++, apparently. We can confirm that it is an executable, that it has apparently a GUI. That might be interesting. If something pops up, we can kind of look into that. We can see that this is a 32-bit executable, so I don't have to mess with 64-bit. We'll take a quick look at some of the indicators. We'll see it ranks some general malware or suspicious activity here, of where we've got some registry modifications to look out for, enumerating network resources. There's sometimes some pretty interesting stuff in here. We can see that it does apt for ASLR, so that can complicate your analysis. Just making sure that you disable that on your virtual machine if you go to match your memory addresses with the disassembler. Today we're not going to get into a disassembler, but we're mostly going to be doing a static analysis. The VirusTotal, it's not going to connect because my date's wrong. Sometimes the VirusTotal indicators will give you a good indication as to maybe what the ransomware is, or if it is ransomware, if a lot of antivirus companies are calling it the same thing. Sometimes that's very useful, but also keep in mind that it is not the antivirus's job to identify a ransomware. An antivirus's job is to just stop it and recognize that it is a ransomware. So sometimes you'll just get a heuristics name of garbage, but that doesn't mean that it's not useful. Taking a look through a few more other things here. If we look at the file header, I am not very versed in the actual PE format, but this gives us some interesting things. Once again, 32-bit, it's executable. We can tell it's not a dynamic linked library, which means it's not a DLL basically. So we can analyze it a little easier per se. We can take a look at some other things here. Let's see if anything else catches my eye. We can see the entry point is in the .txt or the .text section. That's pretty typical, I believe. Once again, here's some entropys on these sections, so it's probably not packed. Here we can see what libraries it actually calls itself. So we'll see it includes the kernel 32.dll, which is pretty much a lot of just standard Windows subsystems. Now here we can get into the imports and see what functions the ransomware actually imports. So this can give us an interesting idea maybe into what type of encryption library it uses sometimes. If we take a quick look here, we can see that it might sleep. Sometimes that'll be like an anti-VM to make things annoying. Terminates a process. Let's take a look here. Got some typical string usage. So one thing that I would notice here is I know for a fact that this is a ransomware sample, but I'm not seeing any specific crypto calls. So that can be an indicator that maybe it's obfuscated or maybe it uses custom encryption. But we do notice, and what will sometimes get me excited, is we do have a call to query performance counter. And there's also a call to, cannot find it. Well, there's another function call that goes along with that. Oh, right next to it, get tick count. And that sometimes might hopefully indicate that there's a weak keygen, but these functions can be used for anything, just generating random numbers for anything. Doesn't mean that we got lucky on something that's decryptable. But taking another look through here, we can kind of see there's a get command line, some environment string stuff maybe. Oh, might check for a debugger, so that's a good indicator that we need to, well, it's marked as an anti-debug. We can also see that there was some enumeration for files, so that's a good indicator that it's going to do something with files. There was a comparing strings. It's interesting. Of course, it doesn't export anything. It's not DLL. There's no embedded resources. Sometimes you will see maybe a ransom note in the resources. Next interesting thing is definitely going to be the strings. So if we just take a look through the strings of the executable, we'll notice a couple of library calls here. So that can be an indicator that maybe these are dynamically called in a way to obfuscate what it's doing. So we'll see, here's our file functions. We've got find first file, find next file, delete file. Those are pretty typical for, the logically what a ransomware needs to do. So we'll just go ahead and scroll through here, see if there's anything else interesting. And hello, we have some calls to the Microsoft Crypto API. So the crypt encrypt function is basically the bread and butter of that API, and that's where, if we were doing dynamic analysis, we're going to want to hook into that function to see what's getting encrypted and how. We've got an import key, which might indicate that there's a static, probably an RSA key or asymmetric key, deriving key, creating a hash. It's pretty typical. It'll actually maybe generate a hash to use as the key. Let's take a quick look through here a little bit more. We've got some, once again, we have some registry actions here. We have possibly a ransom note name. We've got some registry additions to make the ransomware run at startup. That's very interesting. Take a few more look through here. Once again, there's our query performance counter and get tick count. And here we'll see some file extensions. These are likely the white list of extensions to encrypt. Once again, we have a ransom note name. Very interesting string here. Maybe it drops a file to this folder or reads something from there. Not quite sure at this point. We can see here's the string confirming that we are using the cryptographic provider with the crypto API. We have a bat file that might be generated. We have a task kill. Maybe it tries to stop analysis tools or stop an antivirus. Have kind of some garbage. Scroll through here. Oop. Nope, these are just some typical stuff. MSIL, blah, blah, blah. Runtime C++. Sometimes these random strings here with a sequence might indicate certain functions, such as maybe, well, not in this case, but sometimes you'll see like a string of base 64 characters that might indicate that there's base 64 used in some point. Maybe this string could be used as the key, part of the key gen. It's randomly selecting from this exact character set. Just some things to keep in mind when if you get to the point of doing dynamic analysis, keeping a lookout for those strings. Take a quick look through here, and here's another thing you'll probably see in a lot of ransomware is deletion of the shadow copies. That's pretty typical to make it harder to recover data. And we'll see here actually deleting backups. That is very interesting and something good to keep in mind. Scroll a bit through here, but interesting bit of garbage there. And here we go. This looks very interesting. Here we have a ransom note, as we can tell by the HTML. And we had a string earlier that told us what the ransom note was going to be called. So we can read through here real quick. It's been encrypted with RSA 2048, blah, blah, blah. You have a unique something. And of course we can copy this and put it into an own document if we wanted to take a look at that later. Scroll through some more garbage. There's our extensions again. See if there's anything else interesting. Oop. Sorry, my mouse jumped. Okay. Here's probably just some more persistence. I don't typically focus on how the ransomware persists too much, but it's interesting to see that it's going to run some type of script that probably this is for deleting itself after it runs. And that seems to be all that I'd really care about at this point. This looks like a file name that's very interesting. This was actually mentioned in the ransom note above. So we'll take a look here. Sometimes you'll get a debug that shows like the PDB path. That can sometimes be useful for say naming the ransomware if it looks like the author intended for it to be named something. Naming a ransomware can be a little controversial, but I see it as I know that a lot of the antivirus industry recommends against naming it what the author named it in terms of malware. But I think ransomware is a special case because you want to like if I'm going to identify it as something, it's best to make it something that the end victim will actually be able to match up themselves without having to analyze the ransomware. Otherwise, they wouldn't likely be a victim in the first place. So something that they can Google. So usually the ransomware will pop up and have a name or something like that, and that's going to be the first thing they're going to Google. Taking a further look, the last thing I want to look at is sometimes there's an overlay. In actually this case, there was an overlay that is not being detected right now. That is very interesting. Is it because... I have an outdated version of PE Studio. Okay. I thought I had the latest version on here. My apologies. There was actually something very interesting in the overlay that I wanted to point out. I'm going to go ahead and just open the executable in a hex editor to display this then. HXD is a pretty good hex editor. Once again, if you scroll through here, you can also like see some of the strings past the garbage. Yeah, there's our list of extensions, all that fun stuff. There was the ransom note. Here was something very interesting about this sample. We actually have in the overlay on the outside of the PE format, or outside the PE file, we actually have a blob. This is actually a crypto blob for the Microsoft API. And as we can see here, it's an RSA1, which is a public key. There's also some type of like delimiter. Maybe the ransomware uses that to pull it out of its own executable. One interesting thing I'll do here is usually it starts with the 06 is a simple blob. As we'll see here, we can copy this, and I have a proprietary tool that I haven't released quite yet that will actually analyze this blob. So if we paste into here, oops, not the text, I need the actual hex. Copy this. And here we go. I'm sorry, that was not a simple blob. It's a public key blob. And we can see here, once again, it's an RSA key. It is not an encrypted key. In this case, it doesn't matter. It's an asymmetric key, but it could have been a symmetric key that was encrypted by an asymmetric key. We can see it's an RSA 2048 key, meaning we can't break this. And there's the public exponent, and there's the actual format. I can export this to XML and actually view the actual numbers behind the key. So that's kind of some interesting stuff. Next thing I will show, or usually one of the next things I'll do, or even at the same time while I'm doing this on another machine, is I want to actually run the malware and see what it does. Mostly I'm wanting to be able to produce some encrypted files that I can compare, and then I can kind of sometimes get a pretty good insight into what type of encryption algorithm it's using just based on experience. Just kind of looking at the before and after can kind of give you an idea whether it's not always whether it's secure, but kind of give you an idea if you're looking at just something that's just simple XOR, or if it actually looks like a block cipher. You can actually kind of tell patterns if it's like ECB mode, that type of things. I also like to see what the file size changes to, see if the ransomware like dropped a file marker, left any data in there. Sometimes it's an encrypted, the encrypted key or something like that. We'll see. Of course, if you run this in an actual like analysis sandbox, like an automated system, it'll actually give you a breakdown of the processes running and everything that's happening. But I'll do that like after I run it myself. I just want to get some files to snapshot. We'll see that 11 folder. That's very interesting. Or that is actually a folder that it was referencing. And we'll see we do have a ransom note dropped. Here's that unique ID, do not remove. While that's still running, let's go ahead and pop that into the editor and see if that's anything interesting. Just looks like a lot of garbage. This is actually an encrypted key, if I recall right. I'll reveal at the end of the video here what ransomware we are dealing with. Length of 800 bytes is a good indicator that this was encrypted by RSA, which we do have confirmed that there's a embedded RSA 2048 key. RSA 2048, due to the math of it, it will encrypt and leave a ciphertext of 800 hexadecimal bytes. Sorry. RSA kind of produces a particular length based on its bit size, which is very interesting. So we can take a look at the ransom note. And okay, it looks like we're dealing with a Hermes ransomware sample. And here we have the typical, here's how to reach us. Here's another email address. Pay us money. Here they mention that unique ID, do not remove file, which is the encrypted key. That's how, on their end, they use the private RSA key, decrypt that file, and send you back a decryptor. That is unique per victim, the generated key at least. We can see in here, that's kind of weird. It's got like a link to computer management embedded in here. I don't know what that's all about. It's really weird. This comet actually goes back to my computer. That's a really weird shortcut. So I don't really know what this thing's doing here. Now I have on this system some bait files, and we can see they got encrypted. So I have just the basic Windows sample pictures. They're usually good to see some patterns. And then I have some bait files that are just literally a bunch of 0 bytes, and that helps me see if there's any patterns. So I'll take the 0 bytes in here, and if you're wondering, I have this one in here with just a Spanish word, because sometimes some ransomware will like really mess up the file name if it's got UTF-8 characters. So I have just a random Spanish word there just to see if the ransomware handles renaming the file correctly. Sometimes that's very interesting to note when it comes to identifying. So if we take a look here, yep, this got encrypted. And I'm just going to jump to the bottom of the file, see if the entire file is encrypted, and it is. And we'll actually see there is a file marker here, and it's Hermes. So at this point, I would safely call this ransomware Hermes. Everything is pointing to it, the ransom note, the file marker, and once again, that's going to be what the ransom note itself is going to be what a victim actually Googles to get more information on this. So that's very interesting to note here. Once again, we can see, like I said, the original of this file is nothing but 0 bytes, so we can see it's encrypted the entire file. Sometimes you'll notice it cuts off at a certain part, like maybe 1 kilobyte into the file or something. Let's see. Interestingly enough, it didn't hit the My Pictures, it just hit my C root. So that's kind of weird. I also like to use another function of this tool that I developed that I'll open to the public at some point. I like to compare the actual files. So let's take a look at the original file. So an original chrysanthemum.jpg. Now we'll open an encrypted chrysanthemum. And we'll just kind of see, sometimes I'll look in here to see if there's like a pattern. My tool will automatically check if there's like ECB blocks. That's just based on the property of ECB, where the same cipher text is produced by the same plain text. So if it sees that the same 16 bytes are repeating, or 8 bytes in the case of like DES encryption, we'll see that it picked up on some ASCII characters at the end of the file. Ransomware finally finished and launched its ransom note. A little slow there, buddy. We'll see that it found this file marker Hermes. That's very interesting. I see a comparison of the encrypted file to the new file, so we can see it's got an extra 20 bytes. So to me, even though I have a mod 16, which can tell me whether it's sometimes I can tell if it's a block cipher. In this case, it would be a block cipher, because 20 minus 6 characters for the file marker, and as we saw at the bottom here, we have a nice even 16. That's typically, if the original file was not divisible by 16 evenly, and then the new file, the encrypted file is, that's a good indicator that it's a block cipher that's in use, because block ciphers have to output a ciphertext in their bit size. We'll see. Originally, this should have been detected as a JPEG. That's interesting. And then unknown over here. We'll see. I also added recently to my tool that I can analyze whether there's like a crypto blob in the file. If it like left an encrypted AES key in a blob format or something like that. We'll see. In this case, the file name, there's no file name change. Sometimes ransomware it'll add an extension. It might encrypt the file name. It might just encode it. So I have some basic checks for that I'll look at. So at this point, I have a pretty good just a static analysis of some interesting stuff. So we found, first off, we confirmed that this is a ransomware sample before we even ran it. We can see a lot of indicators stating such, especially with having the ransom note in it. We found what indicators we can identify it by. In this case, it has that Hermes file marker at the end of the file. There's no extension, so it's a little harder for victims to necessarily detect that or identify that. I'm not going to go into the dynamic analysis of this one, mostly because it's actually already been done by Fabian Wosar. He did a very good live stream of breaking this ransomware last year, which allowed me to actually literally kind of copy his code with his permission and release a decryptor for the very first version of Hermes. They made a critical flaw in the keygen. You can watch his stream for details on how he discovered that. Just a couple notes on like dynamic analysis myself. I do struggle with that still in terms of locating the keygen. That for me is the hardest part. Sometimes the encryption is not too terrible to discover, especially if they are using the Microsoft API. That's a pretty good dead giveaway. You can just read the documents on how that works, and I've seen enough of it that I recognize how it's used, how to get it, how to dump the key from memory to analyze it, all that fun stuff. It might be for a future video. But I hope this potentially helped in just getting started. To kind of wrap things up, I need to fix the time on my virtual machine in order to connect to a website. That's not today, but that's close enough for SSL to care. Sometimes this is also part of my analysis of the ransomware in terms of identifying if it's one I've seen before, because there's thousands of ransomware at this point, and I can't remember them all. So I will use my own, just a shameless plug for my own website, ID Ransomware. This is a tool that I built for the public to identify what ransomware hit them by just simply uploading an encrypted file and the ransom note. So we will do that. Let's add the encrypted file. Let's add the ransom note, which was, let's grab this one. So we'll go ahead and upload that, and we'll see in a moment here. Once again, we have confirmation this is Hermes. It identified it by the ransom note's email address, the bit message, and it even picked up on that file marker we saw with Hermes at the end. And here's a link to a Bleeping Computer article with more information about the good news. It's decryptable. Once again, here's that link to the live stream on decrypting it. And my post on here's my decryptor. This is one of the very first decryptors I wrote. So it's very, very rudimentary. So fun times. So that has been analyzing a ransomware statically from scratch from the perspective of a beginner. And I hope you tune in for more videos if I have the time to make them in the future. Thank you.